All right, 6.3 day 2 is on direction angles. Let's take a vector. Let's say u is the vector. And we break that down into its components. We know that y is equal to u sine theta. X is equal to u cosine theta. And we can write the vector u different ways. Right here we put it in these brackets, the greater than and less than brackets. And since x is cosine theta, we can just substitute cosine theta and sine theta. If we wanted to use the components with I and j, we would have cosine theta I and sine theta j. And then finally, we could write it as x, which is, again, cosine theta. It'd be xi and yj. So there's many different ways to write a vector. So now let's look at how do we get the angle. Theta is going to be defined as the angle it makes with the positive x-axis. And so when we get into some examples, we'll go into that a little bit more. But if we were just going to take the tangent of theta, well, we know it's sine over cosine, which is y over x. So if we're solving for theta, theta is just the arctangent of y over x. So we can go directly to that if we want. Let's look at example 1. It says find the direction angle, and here's the vector, negative 6i plus 6j. And what's important is that you know what quadrant this vector is in. Well, since here we have a negative 6i, we're going left 6 spots, and plus 6j would be up. So if we draw the vector from the origin, it's just going to be right here. So this is the vector, this vector right here. Obviously, this is in the second quadrant, so we are going to be looking for a theta, a value of theta that is in the second quadrant. So let's just go right to our equation if we just have to find theta. So theta is equal to the arctangent of the y value over the x value. So it's going to be 6 is the y, and negative 6 is the x. If you put that into your calculator, so it's this is the arctangent of a negative 1. You put that in your calculator, depending on if you're in degrees or radians, you're going to get negative 45 degrees, or you're going to get a negative pi over 4. So these angles are not in the second quadrant. These are actually in the fourth quadrant. Well, that's not what we're looking for. And so let's do it in degrees. So what we're going to do is add 180 degrees to the negative 45. So negative 45 degrees, and the reason we add 180 is because the period of tangent is 180 degrees, or pi, and it gives us an answer of 135 degrees. That's the answer we're looking for. If we were going to draw it in, we would go from, again, the positive x-axis. So theta is going to be that. Theta equals 135 degrees. Okay, let's look at the next example. Find the direction angle. So it gives us the vector v is equal to minus 7i minus 4j. So we know that we're in the third quadrant. And so if we just go ahead and put it into our equation, theta is equal to the arctangent of a negative 4 over negative 7. That gives us 29. So 29.75 degrees. Well, that's obviously not in the third quarter. That's in the first quarter. So we have to add 180. And that gives us 209.75 degrees. And that's our answer. Okay, the third example, we have an airplane that is descending at an angle of 45 degrees to the ground. Now, this wouldn't be a commercial plane because they don't do that, but a fighter plane would do it. We want to find the component form of the vector. So let's draw a little picture. So 45-degree angle to the ground. going to be like this. And so this is 45 degrees right here. And it says it's, oh, it doesn't say. So we're going to say it's 500 miles per hour. So here's our vector. So we want to find the component form, except we want to use not the angle 45. We have to figure out what the angle is that it makes with the x-axis. And so here's our axis. So we're looking for this angle right here. That turns out to be theta is equal to 225 degrees. So now putting this in the component form, v is going to be equal to, it's the vector, which is 500 cosine 225 plus, and that's in the I direction, plus 500 sine 225j. So you put these into your calculator. 500 cosine 225 is a negative 354i, and the 500 sine 225 is a negative 354j. So this is the vector, or we could put it in, this is the component form, we put it in the vector form, just with a negative 354 comma negative 354 in the other bracket. So either one is okay. Okay, example 4, typical physics problem. So we have a force of 500 newtons. It's holding a box that's on wheels, and it's not moving. And it's a frictionless ramp, which means we're not counting for any other forces on this other than the weight. And the angle is 12 degrees. So if this force wasn't here, the box would just go rolling down the ramp. And so what we want to do is find the weight of the box. So begin by just drawing a vertical line from the box, and we're going to label that W for the weight, because the weight is always straight down. Now we're going to make a right triangle that has an angle of 12 degrees because it's going to be similar triangles. And so I'm going to do this in a dotted line. So this is going to be perpendicular to the ramp. And so we draw a line that is perpendicular to the ramp. And then we draw another line that is parallel with the force. So this is right here. So here's our right triangle with W being the hypotenuse. Now, because of similar triangles, we know that this angle right here is also 12 degrees. So we want to find this. This is going to be W sine 12 degrees. And that's going to be the same as this force because they're both in the same direction. They're both parallel. So this right here, and I'll fill it in with red, this right here is W sine of 12 degrees. So now we want to solve for W, well, and this is equal to, come up here. So we have W sine 12 degrees, and that is equal to this force of 500 newtons. 500 newtons. So now all we have to solve for W. So 500 newtons over the sine of 12 degrees, and that's equal to 2,405 newtons. I'm not dealing in pounds. So this is the weight of the box. Okay, example 5, another physics problem. We have 3 vectors, each at a different angle, each at a different magnitude, but they all have the same origin. And what we want to do is find the magnitude and direction of a resultant vector, which means we can replace these 3 individual vectors with one resultant vector that has the same pole on the origin point. And so what we're going to do is add up all the x components of these three vectors and then the y components of these three vectors. And again, remember, we're going to take all our angle measurements from the positive x-axis. And so there's only one of them that isn't labeled as such right now, and it's the 150 pound. We have this 40 degrees, so that means from the positive x-axis to here, that's 140 degrees. So that's what we're going to use for that angle. So let's go ahead and start. So the resultant is the sum of all the x components and the y components. So we're going to, each one, for the first one, the 100 pound force is 100 cosine 30 degrees. For the second one, it's 75 cosine 60 degrees, plus the third one is 150, and it's cosine 140 degrees. So these are all the x components. And then the y components, it's going to be 100 sine 30 plus 75 sine 60 plus 150 sine of 140. And this is the y component. So we're going to add these up separately. And so r is equal to, if we add up the x components, so r equals 100 cosine 30, which is 50 square root of 3. 75 cosine 60 is 75 over 2. And 150 cosine 140 is a negative 114.9. This is the I. Then plus, we have 100 sine 30, which is 50. And 75 sine 60 is 75 square root of 3 over 2. And 150 sine 140 is 96.4, and that's J. So now we're going to add up all of the individual I and J. So that turns out to be R is equal to 9.2 I plus 211.35 J. So this is our vector R. We want to find the magnitude. So the magnitude is equal to the square root of 9.2 squared plus 211.35 squared. And that's equal to 211.5. That's the magnitude. Now we need to find the angle. So theta is equal to the arctangent of the y value or j value over x. So it's going to be arctangent of 211.35 over 9.2. And that turns out to be 87.5 degrees. So here we have the magnitude and the angle of the resultant vector. If we were to draw this in, that's the last thing we're going to do. So it's 87.5 degrees, almost 90 degrees, and a little over 200 pounds. So this is pounds. And so it's going to be somewhere, now if I'm going to draw it from the origin, so somewhere kind of like, let me try it again. So I can draw it. So something like that angle. And this would be our resultant. And that, at that angle, takes place, and at 211.5 pounds, replaces all three of those individual vectors. Okay, so that is it for 6.3.